The Gulf of Oman maritime blockade that USS Leyte Gulf had been enforcing for 22 days was not, by the legal definition of the term, a blockade. It was a persistent interdiction posture, a pattern of operations authorized under a Security Council resolution and conducted under rules of engagement that permitted the boarding and inspection of vessels assessed as carrying sanctioned materials, the diversion of vessels refusing to comply, and the use of proportional force to assert the right of approach when a vessel's behavior indicated hostile intent. The distinction between a blockade and an interdiction posture matters in the legal architecture of international maritime operations, and matters less in the tactical reality of being the ship that enforces it. The Leyte Gulf had been the enforcing ship for 22 days, and in those 22 days the number of vessels that had challenged the posture, evaded the approach, or communicated through their behavior rather than their radio. That compliance was not their intention had been consistent enough that the watch team's threat assessment had settled into a particular kind of steady-state vigilance. Not alarm, not complacency. The middle ground that experienced watchstanders occupy when the threat is real, the pattern is known, and the only variable is timing. At 1:47 a.m. the timing resolved. The EW system flagged 3 simultaneous radar activations at 1:47:02 a.m. 3 separate fire control radar systems, each with the emission signature characteristic of the ROD 500 pre-launch sequence, activating within a 1-second window from 3 positions distributed along a 40-kilometer stretch of the Iranian coastline northeast of Bandar Abbas. 3 simultaneous activations. Not a single battery conducting its normal engagement cycle. 3 separate batteries, each with its own crew, each receiving the same launch command at the same second, coordinated to produce a salvo that would arrive at the target in a time window narrow enough that the defending ship's interceptor inventory would be divided among simultaneous engagements. The RAD 500's characteristics were not unknown to the Leyte Gulf's watch team. The midnight intelligence brief had included the updated capability assessment, and the watch officers had discussed it at the brief in the manner of people who take a threat seriously without allowing the seriousness to become paralysis. What the brief had emphasized, what the TAO had underlined in his notes and had specifically addressed with the watch team, was the weapon's terminal jinking capability. The pre-programmed lateral displacement maneuver that the ROD 500 executed in its terminal phase, and that the SM-2's intercept solution was vulnerable to. The Philippine Sea's engagement had provided empirical data on that vulnerability. The data was in the updated assessment. The watch team had it. What the brief had not covered, because it had not yet happened, because the operational intelligence that would have flagged it had not yet been assembled into a report, was the 4th element of the attack package that the Iranian strike planners had prepared. The 3 ROD 500 batteries were the primary strike. The 4th element was different in kind. The modified Shahed 136 maritime variant had been deployed from a vessel in the background shipping picture 18 minutes before the ROD 500 activation. It had been flying at wave-top altitude on a navigation-only guidance mode. No active seeker emissions, no radar signature above the sea clutter threshold. No thermal signature distinguishable from the marine environment at its cruise altitude and speed. On a pre-programmed waypoint route that had been designed to bring it to a terminal approach position timed to coincide with the maximum engagement saturation of the Leyte Gulf's defensive systems. Not before the ROD 500 salvo. Simultaneously, the drone's navigation timer had been set to transition from waypoint guidance to terminal attack guidance at the moment the missile batteries fired, at which point the drone would activate its electro-optical terminal seeker, acquire the Leyte Gulf's hull, and commit to its final approach. The weapons designers had identified the specific 60-second window in which a ship managing a 3-missile ballistic intercept sequence would have every fire control channel, every radar processing thread, and every tactical decision committed to the high-altitude, high-speed tracks descending from above. The Shahed 136 would arrive from below, from the sea surface, from the bearing that the ship's fire control geometry was least able to address simultaneously with the ballistic engagement overhead. The RAD 500 launches were detected at 1:47:04 a.m., 2 seconds after the radar activations. The fire control system processed all 3 tracks simultaneously and began computing intercept solutions for each. The SM-2 extended range battery committed its first 3 interceptors at 1:47:09 a.m., 5 seconds after launch detection, with the 3 inbound missiles at the beginning of their ballistic arcs and the intercept geometry as favorable as it would ever be. The TAO had reviewed the auto special mode's commitment decision in the 0.8 seconds between the fire control system's recommendation and the launch, and had confirmed it. 3 missiles, 3 interceptors, sequenced at 2-second intervals from the VLS. The surface picture was clear at the time of the missile detections. No anomalous contacts. No fast-moving inbound tracks on the surface search radar. The Shahed 136 was below the surface search radar's detection threshold at its current altitude and range, and it would remain so until it activated its terminal seeker and climbed from wave top to its final attack altitude at a range close enough that the time between detection and impact would be measured in seconds the ship did not have. The first RAD 500 intercept occurred at 1:47:28 a.m., 19 seconds after the launch. The SM-2 achieved a direct hit on the first missile's mid-course phase before the terminal jinking maneuver had been initiated. Clean. The debris field dispersed high and wide. The second intercept 40 seconds into the engagement produced the result that the updated capability assessment had predicted. The RAD 500's terminal jinking maneuver displaced the missile by 14 meters laterally at the point where the SM-2's intercept solution predicted it would be. The miss was 12 meters. The second RAD 500 continued its descent. The phalanx committed to the second RAD 500 at 1:48:14 a.m. The engagement produced 2 burst impacts on the airframe that disrupted the weapon's structural integrity without causing immediate flight termination. The RAD 500 continued, damaged, its trajectory altered by the aerodynamic disruption from the structural damage, its warhead still armed. The altered trajectory changed the impact point from the waterline amidships to a descending approach on the ship's aft section. The warhead detonated at 1:48:19 a.m. against the aft VLS battery housing. The structural cover of the 16 cells in the Mark 41 launcher positioned on the ship's stern. The third RAD 500 was still in its terminal phase. The aft VLS detonation was, in the damage sequence of the engagement, the first event. The second event arrived from an entirely different direction 14 seconds later. The Shahed 136 had activated its electro-optical terminal seeker at 1:47:09 a.m., simultaneously with the RAD 500 launches as the attack timeline had been set. It had spent 64 seconds flying its final approach at wave-top altitude on the bearing that the ship's fire control geometry could not address, while 3 ballistic missile intercepts were consuming the defensive architecture's attention. At 1:48:13 a.m., 1 second before the phalanx engaged the second RAD 500, the surface search radar finally resolved the Shahed 136 as a distinct contact at a range of 900 meters. 900 meters at the Shahed 136's approach speed was 6 seconds. 6 seconds was not enough time to commit the SM-2. It was barely enough time to alert the phalanx. The phalanx had been committed to the second RAD 500. The CYWS mount was oriented upward, tracking the descending ballistic threat, firing into the sky at an angle that was exactly wrong for a sea-skimming contact approaching from the port quarter at wave-top altitude. The system received the new track data from the fire control computer and began its slew from its current orientation to the new bearing. The mount's maximum slew rate is fast, designed specifically for the scenario where a new threat appears while the system is engaged with an existing one. But fast has a physical limit. and the 6 seconds available were at that limit's edge. The phalanx fired its first burst on the Shahed 136 at 1:48:18 a.m. 1 second before the Rod 500 warhead detonated against the aft VLS. The burst impacted the drone's airframe at a range of 300 meters. 1 second later, the Rod 500 hit the stern. The simultaneous detonations, one at the hull's stern, one in the air 300 meters away, arrived as 2 events separated by a fraction of a second that the crew experienced as a single compound impact. The Shahed 136 detonated at 1:48:20 a.m. Not against the hull. The phalanx burst had disrupted its guidance and structural integrity enough that the terminal seeker lost its lock, and the drone's final approach deviated from the hull surface. It detonated in the water 41 meters off the port beam. The pressure wave from the warhead detonation, a shaped charge optimized for hull penetration, arrived at the hull as a laterally directed shock load rather than a direct penetration event. The shock load was sufficient to trip the No. 2 gas turbine generator through its vibration protection system, and to open a weld seam in the port side hull plating at frame 191 that had been previously documented in the ship's maintenance records as a seam requiring weld repair at the next dry dock availability. The RAD 500 warhead detonation at the aft VLS battery was the more serious of the 2 events. The aft VLS battery on a Ticonderoga-class cruiser is structurally similar to the battery on any Aegis-equipped surface combatant. A 16-cell magazine below deck, a launch cell array above deck, and a weather deck covering structure that protects the cells from the maritime environment and provides the structural support for the cell hatches. The Rod 500's warhead, which had been altered in its terminal trajectory by the phalanx structural disruption, struck the weather deck covering at the junction of the 3rd and 4th cell rows rather than the waterline impact point its original trajectory had been targeting. The detonation energy propagated downward into the VLS cell array rather than laterally into the hull structure. 4 of the 16 aft VLS cells were directly within the detonation energy's primary propagation path. 3 of the 4 contained live weapons, 2 SM-2 Block 3B missiles and 1 Tomahawk land attack variant. The 4th cell was empty, having been fired in the first salvo against the Rod 500 salvo. The 3 cells containing live weapons were subjected to the thermal and blast energy from the warhead detonation at ranges between 2 and 4 meters. The SM-2 propellant grain in cell 12 ignited at 1:48:21 a.m., 2 seconds after the detonation. Not the SM-2's warhead. The fuse and arming system held against the thermal event, as it had been designed to. The rocket motor. The solid propellant grain in the motor section of the missile began burning from the uncontrolled heat input in the same failure mode that the aft VLS casualty on the USS Monterey had produced. Solid propellant combustion in a confined magazine space, producing temperatures that the surrounding structure could not sustain, driven by an oxidizer that was carried within the propellant grain itself. The magazine fire in the aft VLS was burning at 1:48:22 a.m. The damage control response sequence was already in motion. The damage control officer had been at his board since the RAD 500 detection, and the general quarters alarm that had sounded at 1:47:06 a.m. had moved the DC teams into their pre-positioned stations before the first interceptor had left the launcher. When the aft VLS detonation alarm activated and the magazine fire alarm followed it within 2 seconds, the DC team assigned to the aft VLS station was 41 meters from the magazine flood valve station. They ran. The lead petty officer reached the valve station at 1:48:37 a.m., 15 seconds after the propellant ignition. The magazine flood valve for the aft VLS was a manual wheel valve. Not a remotely operated valve, not an automated system. A physical steel wheel on a pipe that controlled the seawater flood circuit for the aft magazine space. The system was designed identically to the magazine flooding system that had been used on the Monterey because it was the same system, the same design specification, the same installation standard, the same flow rate. The design had been proven effective when applied within the timeline that the fire's heat development curve allowed. He opened the valve at 1:48:39 a.m., 17 seconds after propellant ignition. The seawater entered the aft VLS magazine space at 2,000 liters per minute. The temperature in the space had been climbing since ignition. 17 seconds of unchecked solid propellant combustion in a magazine space produces temperatures that the steel structure begins to respond to at the higher end of their range. The water entry produced the characteristic steam and hiss of seawater against hot metal at scale, a sound that the DC team in the adjacent passageway described in their post-engagement statements as the space fighting back against the water before the water won. The propellant combustion rate began declining at 1:48:58 a.m., 19 seconds after the flood valve was opened. The temperature curve reversed direction at 1:49:11 a.m., 32 seconds after the valve was opened. The propellant combustion was extinguished at 1:49:44 a.m., 65 seconds after the flood valve was opened, 82 seconds after ignition. The aft VLS magazine fire was out, 16 cells flooded, 3 weapons destroyed by fire and flooding. Their explosive fill intact, but their propellant, electronics, and structural integrity compromised beyond any operational use. 13 cells in the aft battery retained their weapons. Those cells that had not been within the primary blast and thermal propagation path had been protected by the steel cell walls, which had absorbed the energy between the affected and unaffected cells. The 13 retained weapons were assessed as potentially viable, pending a full technical inspection that could not be conducted at sea. The aft VLS battery was offline. The ship had lost 16 cells of engagement capacity, 1/7 of her total VLS load. The third Rod 500 had not been forgotten. The third missile had been the lowest priority of the 3 in the original intercept sequencing because its trajectory had placed it on the longest time of flight of the 3, giving the fire control system more time to address the first 2 before committing to the third. The fire control system had committed a second SM-2 to the third missile at 1:47:51 a.m., while the engagement with the first 2 was still in progress. The second SM-2 had been tracking the third Rod 500 through its mid-course phase and was closing to its intercept point when the aft VLS detonation occurred. The detonation's shock load, transmitted through the ship's structure, reached the fire control system's processing hardware at 1:48:19 a.m. and caused a momentary data dropout in the fire control uplink channel that was feeding corrections to the SM-2 in flight. The dropout lasted 0.7 seconds. In those 0.7 seconds, the SM-2 flew without updated targeting corrections toward the intercept point that its onboard guidance had last been provided. The third Rod 500 had begun its terminal jinking maneuver 0.4 seconds into the uplink dropout. The SM-2's last guidance update had not incorporated the jinking displacement. The SM-2 missed the third Rod 500 by 22 meters. The third Rod 500 was at its terminal approach phase. The phalanx on the bow, the forward CYWS, which had not been committed to either the aft VLS engagement or the Shahed 136 engagement and whose orientation was clear to the sky in the threat sector, acquired the third missile and fired at 1:48:41 a.m. The engagement was at a range of 1,200 meters and the Rod 500 was descending steeply. The CIWS fired 3 bursts. The first burst impacted the airframe. The second burst reached the guidance section. The third Rod 500 deviated from its terminal approach vector at 1:48:43 a.m. and impacted the water 114 meters off the starboard bow. The pressure wave from the water impact reached the hull as a sharp, forward-directed shock that was felt throughout the forward spaces. No hull breach. No fire. The forward optical sensors registered the impact and the sonar supervisor logged the underwater detonation of the warhead at impact depth. Another number on the board. Another entry in the record. The port hull weld seam failure. The second event from the Shahed 136's water detonation was producing flooding at a rate of 60 liters per minute into the void space at frame 191. Not a crisis by the standard of the night's other events, but not ignorable. The flooding was below the rate that would threaten the adjacent spaces in the immediate term, but it was above the rate that the passive drainage could manage without active pumping. And active pumping required a team in the void space with the portable unit from the DC equipment locker 2 compartments forward. The secondary DC team reached the flooding space at 1:49:28 a.m., 68 seconds after the Shahed 136 detonation. The weld seam failure at frame 191 was a linear fracture of approximately 40 centimeters along the existing maintenance-documented seam. The crack that the ship's last structural survey had flagged as requiring repair had opened along its full documented length under the lateral shock load. The temporary repair was a conventional approach. Backing plate positioned against the interior hull surface over the fracture, hydraulic bladder inflated behind it. The components were in the DC kit. The procedure was standard. The team had the flooding controlled at 1:56:14 a.m., 7 minutes and 44 seconds after the hull event. At 1:56:14 a.m., the Leyte Gulf had controlled all active flooding and fire casualties. The aft VLS magazine was flooded and offline. 16 cells lost. 13 potentially retained. The port hull void space was sealed. The number 2 generator had been manually restarted and was back online at 1:51:17 a.m. The vibration trip from the Shahed 136's water detonation had not damaged the turbine, only tripped the protection system, and the restart had required 3 minutes and 17 seconds of procedure execution. Full electrical generation was restored at 1:51:17 a.m. The ship held her blockade position, not because the fleet commander required it. The damage the ship had sustained would have justified a request for relief, and the request would have been granted. The Leyte Gulf's commanding officer assessed his ship's remaining capability at 1:57 a.m. Forward VLS battery intact with 48 cells operational. Both phalanx systems operational, propulsion and steering fully functional, radar and communications fully functional, engineering plant at full capacity. He assessed the mission requirement. The blockade position needed to be held or the interdiction corridor would have a gap that the Iranian maritime logistics network would exploit within hours of detecting the Leyte Gulf's departure. He held the position. The relief asset arrived 7 hours and 43 minutes later. The Leyte Gulf transited to Bahrain at 9:43 a.m. Her aft VLS flooded and silent, her forward battery loaded and ready, her crew standing watch on the same rotation they had maintained for 22 days. Here are the numbers when the transit to Bahrain begins. 22 days on blockade enforcement before the engagement. 3 Rod 500 batteries firing simultaneously within 1 second. 1 Shahed 136 maritime drone positioned, and time to arrive during maximum defensive saturation. 17 seconds from propellant ignition to flood valve open. 82 seconds from propellant ignition to fire extinguished. 0.7 seconds of uplink dropout that caused the SM-2 miss on the 3rd Rad 500. 16 aft VLS cells flooded and offline. 13 potentially retained weapons requiring technical inspection. 60 liters per minute, flooding rate from the port hull weld seam. 7 minutes 44 seconds to seal the weld seam fracture. 0 fatal outcomes among the crew. 7 hours 43 minutes holding blockade position after the engagement before relief arrived. The Iranian strike architecture had been the most sophisticated yet directed at a U.S. Navy surface combatant in this theater. 3 ballistic missiles on a simultaneous firing signal, timed to arrive in a sequence that forced the SM-2 battery to commit all 3 interceptors to the first 2 missiles, while the 3rd missile's longer time of flight gave it a later, less covered approach. A 4th weapon, the Shahed 136, pre-positioned and timed to arrive at the moment of maximum defensive commitment overhead. The uplink dropout that the aft VLS detonation shock caused was not planned. It was a consequence of the first weapon's success that the planners had been unable to model. It was the only element of the engagement that exceeded their design. And it had still not been enough. The flood valve that opened at 1:48:39 a.m. had been installed at that position by engineers who had studied what happened when it was not opened in time. The weld seam that the DC team sealed at 1:56 a.m. had been documented in the maintenance records. The fracture that an inspection had found, logged, and scheduled for repair had been available to the crew as a known weakness that the shock of a warhead detonation 41 meters away would stress. They had not been able to fix the seam before the engagement. They had the kit to address it when it opened. The blockade position held for 7 hours and 43 minutes because a ship that has absorbed a aft VLS magazine fire, a water-detonated drone shock, and a near miss from a deflected Rod 500 is still, if her crew is doing their job, a ship.